Hi, my name is Etienne with SIGA. Today we are going to talk about different strategies on how to achieve an airtight and weathertight building envelope. Today's workshop will have three parts. First, we're going to look at the question why airtightness matters. Secondly, we are going to look at different strategies on how to achieve an airtight and weathertight building envelope. And thirdly, we are going to do a live demonstration right here on this mock-up where I will show you how to install a weather resistive barrier as well as how to pre-flash this opening. So let's do it!
The world, as we can see it here from space at night. And what's very interesting, if we look at this picture, we can really see the hubs of human civilization. How? Well, simply by looking at all the lights that we use at night. Now, if you're talking about energy consumption, there are three main sectors. There is transportation, the industry, so producing goods, and housing, that we can divide the energy consumption in. 50% of our global energy is used today to heat, cool, and operate buildings. So with that, it makes it the biggest sector of energy consumption. SIGA strives for a world of zero energy loss buildings. So that means our vision is to only build homes that are not losing unnecessary energy. So we're still using energy to operate them and have light in it, but we really want to make sure the envelope of the building is completely airtight so we avoid losing valuable resources. We manufacture the following products. We have weather resistive barriers such as the MyVest. We have different tapes that you can use either on the interior or the exterior of your building to air seal it. And we also have interior vapor retarders, and we will have a look very soon on how they are installed in the field. On the top here you can see a project in Portland, Oregon, the Portland Nature Conservancy building. Here they went with an exterior airtightness and weather resistive layer. They used the SIGA MyVest 500, that blue membrane, to cover their dense glass, and Wigluf to tape all the seams, windows, overlaps, making sure the whole enclosure is airtight. So more kind of a commercial application. On the bottom, same product, but used in a residential setting. Absolutely possible as well. So let's start with the question, why should you pay attention to airtightness in the first place? Okay, what are your benefits? What's in it for you? Why should you even consider doing that? The number one reason to build airtight is occupant comfort. Only if you live in an airtight house that is free of any drafts, you will have maximum comfort. So that's a very important, almost universal value, I would say, for any homeowner. He just wants you to be comfortable and not feel any drafts in winter or summer. The next reason is to save energy. Here we look at the energy model that was done for this house in the picture. And what the modeler did here, he wanted to show to the homeowner that there is an energy saving if he builds the home more airtight. Right now, this house needs about 11 kilowatts per hour per square meter at 0.6 air exchange. So that's the passive house level. That's like the gold standard. Now, if we compare this to an airtightness level that is not as favorable, let's say 10, you can see with an air exchange rate of 10, we just tripled our energy demand for this house. So there is a huge saving potential if we build airtight. Number 3, to avoid building damage. An important part of building airtight is to make sure we have no uncontrolled airflow through our wall or through our assembly. It can be a roof as well in general. Why does this matter? Well, very simple. With air, also moisture can travel into our walls. And if we have moisture that meets cold surfaces in our wall, we always have a condensation risk. And condensation will commonly lead to mold in the long term. So to avoid building damage of that nature, we will have to build it airtight and seal it off well. And here's a good example of how much moisture you can have in your building. Usually the highest amount is actually during construction. Here they are just pouring the concrete floors, and you can see on that 6mm poly that they installed over the window, the water is just dripping down. It condensates and it's dripping down. There's gallons of water that are introduced to our building during regular construction stages. Here we have another example of moisture. Here the reason is actually convection. So what happened here, this vapor barrier wasn't properly taped, and the warm air had a chance to get behind it and condensate, and we can clearly see all these water spots, wet spots. There is a lot of moisture that got into that ceiling. What can happen is this, and that's a very severe example of an untreated moisture problem. Next, mold will follow, and with mold over time, it just eats away, it rots away your wood. You can end up being at a point where you're going to have structural issues, and then it becomes not just a health risk in terms of breathing, it becomes a health risk to even be in that building because it could collapse. So now, after looking at why it's important, let's have a look at how does it get done and what are ways to get your project airtight. One air sealing strategy is actually to address your air barrier from the interior. In this picture, you can see a white membrane called Siga Mirex. This is a smart directional membrane that's used here to protect your walls from any warm, humid interior air. So it stops it at the source, and therefore is a great choice for all projects, for example, where you plan on using blow-in cellulose. Another approach is to have an air barrier mid-wall. In this case, what the contractor chose to do was to tape his sheeting. So we have here plywood sheeting and all those white or white-gray tape lines that you can see, that's Wiglöf. So by simply taping all those joints, they were able to create a good air tightness for that building. It's also an approach that has the advantage that it is long-term well protected. There isn't so much a risk of, if you have an interior barrier or exterior barrier, that it gets damaged once it's covered up. Okay, it's a little bit hard to get to. Then, of course, one of the most famous approaches that is done is to use an exterior air barrier. So often the weather resistive barrier, if taped correctly, you can see in this picture there all the overlaps are taped, they taped all the penetrations, and with that they made this air barrier complete. A very important element of creating an airtight envelope is to start with the question, what's your project goal? How airtight do you want to be, and how do you get there? By applying different methods. One method is called the red line method, and it's relatively simple. If you look at your plan, you take a red pen and you follow along every single element. So that starts, from your base joint over your window connection, and then you go through the roof, and you really want to make sure and ask yourself, is it airtight, and how are you going to create that? For example, with a window, the glass will be airtight, but then how is the frame connected? If you have penetrations, how are those sealed? So that's called the red line method. Then, talking about different details, another element is to really start to think about tricky details, such as rim joist, base of wall, supported balconies, canopy roof. So there are a lot of sometimes even tricky details that you really have to think in advance, how am I going to air seal those before you're actually starting to build, because there are certain details that are going to be really difficult to get to. For example, the top plate of your wall is going to be very difficult once the trusses are already set. It's much more time consuming to tape around trusses rather than just to apply a short sheet of membrane during construction. That brings me to product selection. You have different choices of products that you can be using, and what's very important, if we look at this picture, we have to ask ourselves, what are we looking here at? Is this a weather resistive barrier or is it an air barrier? And in our case, the membrane that has been used is for sure a weather resistive barrier, but what I can tell with a high degree of certainty is it is not going to be a great air barrier. And why can I say that? It's maybe a little bit hard to see, but I will try to indicate that there are multiple areas where this membrane has not been taped. So the overlaps aren't taped. That means it's not going to be airtight. Other products that are used in the market are, for example, foam. Here on the right side, it's a spray foam. It has been used to seal the window cavity. And foam is a great insulator, but not a great air barrier. Why? Because foam has a tendency to crack over time. It is not a product that stays the same at the time. It starts to shrink, and therefore with it goes the air tightness. So definitely something to think about. Also, if you look at tapes, are these tapes designed to withstand building movements over time? Is it flexible enough to be used, for example, around pipes, or did someone just really stretch them very hard? So these are questions you have to look at. Here we have another example on a regular basis in North America. This is spray foam. A few things to point out. First of all, big question mark is going to be here. If you look at that base plate connection, that one wasn't foamed at all. Also, a question mark that we have here is the thickness of the foam, especially if you want to work with a closed cell spray foam. You need a certain thickness so it will act as your vapor barrier. Is that given or not? Or here some other tricky connections that you want to pay special attention. And then a very common one is here, well, how is this box sealed and is that airtight or not? And then here with spray foam, once again, we have a similar challenge. Is it going to shrink? Talking about airtightness and different materials, we also have to think about going to have different connections. Okay, so are we able to connect steel, concrete, wood, plastic, and so on and so forth? There's so many construction materials, and are the products that you choose, can they really handle this? Do they require special primers or any surface treatments that you may are aware of or may not? So keep that in mind. UV exposure, definitely also an important point that you want to consider is the product. Can it be exposed to the UV over a certain amount of time? Is it permeable enough for the climate you're building? Or am I going to have an issue there because it's, for example, impermeable? These are all questions. Sometimes it also comes down to sequencing. Was my window installed correctly? Did it maybe leak somewhere? So that we don't end up with pictures like here. Upside conditions, part of your planning. When are you going to install it? Is it going to be midwinter? And if we have a cold winter, if you are in a cold climate, you do have to consider there are a lot of products that you can't use once it's below 40 degrees Fahrenheit. I've seen installers sometimes using heat guns and trying to trick the elements. I mean, you may get it to work or may not. This is something that's very important. Always make sure that the manufacturer recommended application temperature is followed so that you are covered as well once it comes to the warranty. You don't want to end up in a situation where people start to be like, well, on that day it was actually too cold for you to use it, and you're going to be stuck with an issue. Also, of course, water, moisture, if you're more in a rainy climate. I hope it's not going to be that flooded as we see it here in the picture, but really make sure that you have dry surfaces, that when you apply the product, that you actually make sure this is going to be a long-term good installation. That brings me to what preparation is needed. I think first and foremost, the guessing game out. There is a bunch of information out there from manufacturers. There are, in our case, we have installation guidelines, instruction manuals, we have videos, there are blog posts, and you know, in some cases the manufacturer is just a phone call away. Just pick up the phone, ask if you're not sure. Don't guess. There is a lot of information there. Make sure you use it. Next, blower door test. Definitely something I highly recommend on every job site if you have a certain air tightness goal, and more it becomes required anyways. Blower door tests, recommendation is to always do 2 tests, one mid-construction. You can see this is actually a mid-construction test. This blower door test will help you to detect leaks. It's very normal to miss a spot here and there. If you do a blower door test, mid-construction you get a chance to fix it. Sometimes it simply means to put another tape over an area that you may have forgot. You're done. The last or the final blower door test is once it's all drywalled in, once the building is kind of finished, and you won't really be able to get so quickly to certain points, and therefore always make sure you do 2 and you test. So if you sum up, okay, so material selection and proper product installation is key to build airtight, okay, and there are 3 P's that you need to remember: pick the right product, okay, plan ahead, and then prepare well so that you know exactly what to expect and how to.
So now that we have covered our 3 P's for building air and weather tight, let's jump into installing our weather resistive air barrier as well as pre-flashing our rough opening. Today we are going to be working with a mechanically attached membrane. It's called the Siga MyVest. Siga MyVest comes in 2 sizes. The one size here, that's actually a 5-foot roll, but it also comes in a 10-foot roll. The product is very durable because it is manufactured with 3 layers. You have a protective layer on each side, and in the middle, like in a good sandwich, kind of the main part is a membrane, and that membrane protects the building from any water infiltration, and at the same time, it is permeable. So this product has a permeability of 54 US perms, and that allows your wall to dry out very quickly and efficiently. To install MyVest, you will need a few tools. One of the most important ones is actually our guideline, okay, which covers almost every detail that you can imagine. Next, you want to make sure you have a tape measure, a chalk line, a cutter knife, a stapler, then something to permanently attach it, for example, plastic cap nails as an option. And last but not least, you're going to need a hammer. First step, we want to establish a level. And today we're going to work with a 5-foot roll. Therefore, I'm going to measure 5 feet. Okay. All right, there we go. Okay. And by simply using a chalk line, I connect those, and voila, here we have a perfect line for straight installation. Next, I'm going to measure our wall, and based on the measurements, I will pre-cut MyVest to length. Once I have my wall measurement, I will add a minimum of 4 inches on both sides, because I will wrap around the MyVest around the corner to create a continuous seal. So with my measurements in mind, I can now go ahead and cut MyVest to length. What comes in very handy when doing so is the MyVest has a 4-inch grid in it. So with that, I don't even have to measure the membrane. I can just visually see where to cut. And a little trick before we start cutting, I don't start on the top here. I'm actually start about 1 inch below, and that gives me a lot of stability when I'm actually cutting the membrane. All right. Now the next step for a good installation is to roll it. Voila, here we go. And now we are ready for our next step. So with my pre-cut piece, I can now go ahead and install it on my wall. To do that, I'm gonna use a stapler. So as you can see, I'm distancing my staples around 24 to 36 inches apart. The purpose of this is to temporarily fasten my weather resistive barrier. So next we are going to install our top part of our MyVest, and let me get up here. Quick detail I want to point out, and that's actually very crucial for your air sealing. On our top plate here, before we set our trusses, we have installed a strip of MyVest. It extends on 4 inches to both sides, and the goal here is we're going to connect it with our field membrane here, and with that we will create a continuous air seal throughout that intersection of the building. And I've pre-cut the piece, and I made sure that we have enough material for our 4-inch overlap. That's the minimum we need for vertical and horizontal overlap like this one. And then on top, once this is installed, we will just fold down our pre-strip there. All right, so let's go ahead. Okay, so now with our WRB temporarily installed, we are going to air seal the overlaps, and our first overlap is going to be the middle overlap here. For that we're going to use a tape. It's a 2.4 inch wide tape. One quick trick though, you probably will notice this roll is big enough to fit around my arm, so this comes in handy when I'm going to install it. What's very important, this is a pressure sensitive tape. What that means is we do have to roll it on well. If we don't, you get things like that, and water could potentially jeopardize our seal here. So make sure you put good pressure on, for example, with a roller. Okay, perfect. Now that's permanently sealed. The next one is going to be our top seal here. So remember, very important connection. We have here our strip that comes from the top sill. Grab my roller one more time, and also here make sure we get a good squeeze. Now we could think we are done, but we are not. There is a very important detail that I see gets often forgot on the job site, and that's actually the base joint. So as a base joint, we refer to the connection where our wall meets our foundation. Our foundation is often concrete, which poses an additional challenge. Why? Well, concrete is not a great substrate to stick to. It's usually dusty, and so a lot of tapes require primer. Double check if the tape you are going to use needs primer. Orsiga has a tape that doesn't require any primer. It's called Fentrim. For this application, we're going to use the Fentrim 4-inch. The minimum tape width we need on concrete is 2 inch. And thanks to this split backing, that's going to be a super easy install. We want to start with the bottom part to ensure we have that minimum width. Fold it along the split backing, and then we can nicely squeeze it underneath here. Once again, here we want to make sure we put some good pressure on the tape. For that application, I actually really prefer the squeegee over the roller. We're going to remove the second backing paper, run it along our sheeting here. Okay. And now we're going to do the final taping, very simply fold it up onto our weather resistive barrier. Give it a good squeeze. All right, so from an installation point of view, we will consider this a temporary installation. We want to make it now permanent, and how we do that, there are multiple options. We can, for example, install battens that will also serve as a rain screen later. We can use cap nails or cap screws. For today, I choose cap nails. It's going to be quite an easy install, and let me show you how that's done. So the typical distance between these cap nails is 24 inches. It can go up to 36. That depends a little bit on the manufacturer of those products, so ask them as well. Me here, I'm going to go for around 24 inches. All right, so at this point, let's talk a little bit about tape and a few things that you should consider when you're selecting a product. Number one is the adhesive strength. So you really want to work with tapes that are not just working when it's 68 degrees outside, but also when it gets warmer or even more importantly, colder. Next point is compatibility. Often when it comes to tape, you are connecting different substrates. They react differently, they expand, they contract. You really want to make sure that the tape can actually handle that. Another factor that is important is permeability, especially with a product like this where you build a very permeable wall that can dry. So you want to use for sure a semi-permeable to a permeable tape. And last but not least, we have another weather factor, that's UV. Make sure that the product can withstand UV so that it's not going to fail during the construction or after. We are done with our cap nails now. As of where do we place them? We place them over our studs. So that's kind of an important thing. We want to hit our stud, so mark the studs prior to installing. So the next step is going to be to cut our membrane. We're going to cut it flush to the rough opening. I typically start on the upper corner here. I find it easier to extend the blade a little and just run it along my interior sheeting. Okay, do this here too. Okay, now the bottom I also gonna cut flush. For the head, and that's an important one, we want to overextend by 1 inch, kind of that line from before. And then we have to do a 45-degree angle, 9-inch cut, okay? Okay, gonna use a very small piece of tape. And with that tape, I will flap that open here. Okay. Once the rough opening is fully protected and the window gets installed, we will just take this little head down and have a very, very good protection for the head of our windows. All right, with that being said, let's move to the next stage, and that's flushing our window. Now for window flashing, what's important to consider is, first of all, the sequencing, okay? So we always want to start from the lowest point. And the reason for that is we want to make sure we shingle everything correctly. Now water can potentially float down our facade. And so for us, goal number one is we really want to avoid any reverse slap. Because if we have reverse slab, the water can sit there and potentially penetrate our weather resistive barrier. All right, so sill first. How do we do the sill? We use 6-inch tape. That's also Wiglöf. It's a little bit a wider version of the one we used up here. And the first step is measuring the rough opening, okay? We want to overextend each side by about 2 inch. In my case, as you can see, I have a few of those cap nails here. So I definitely want to make sure I cover those well. Little tip on how to cut it. For me, the easiest to cut tape is kind of take it between the legs and then just make one simple cut. Another trick, this tape has a split backing. That split backing is quite nice because we can work with one piece at a time or one half at a time. And what I found very helpful is to simply fold it along that split backing, okay? And with that, it's not sticky yet, and we can really nicely position this sill tape. That's exactly what I'm gonna do now. Right? Okay. Right. So once again, an important point here is, same as above, we have to make sure we put some good pressure on this tape, really activate that adhesion. Once that's done, we're going to come to our corner piece. We have to do 2 small cuts, one on each side. And the easiest way to make that cut is not from the top or anything like that. Just cut along that fold. It goes super easy. You basically cut kind of same direction as the wall is. Now we come to the taping. You get the best results if you start from the middle and work your way out into the corners and up the jambs. Also an important tool here is the Siga Squeegee. It will really help you to get nice into those corners. All right, so let's do that. I'm going to remove my backing paper here. Fold it nicely, okay? Work my way towards that corner. Use a squeegee, squeeze it nicely in here, okay? Do it one more time on the other side. Okay. Okay, perfect. Give it some rolling, and the first part of our sill flashing is done. Now we have the second part, and an important part is always the corner, often a weakness if it comes to window flashing. And so we have created a method where you do not need to cut in that area. And how can we do that? So Wiglöf is very flexible, and this is kind of the secret how we can do corners without cutting. So let me demonstrate this to you. I can really bend this tape to quite an extent. And so we're going to make use of that characteristics. Now let me show you how the corner is done. So first, we want to pre-cut a piece. We're going to do the width of the rough opening plus 3 inches. Then we're going to cut off kind of, we call it the dog ears. And we are ready to install. Once again, making use of that split backing by installing one side first. Remove the tape, do the second side, all right? And now, when it comes to the corner, there's a little trick. I like to kind of use my thumb and really make sure that right around that edge of the corner that we have really zero buildup. Repeat the same step on the other end. Okay, Once again, use the thumb a little, stretch it out, and voila. Hold on. Next, we will address our jambs, the window jambs. For that, in this application in particular, we are going to use the 6-inch tape again, so we switch back. Reason is, the way our window is going to be positioned, we want to make sure we fully cover the entire window once installed. And therefore, we are using a 6-inch. Okay. Here, in terms of measurement, on the bottom, we want to make sure we cover the bottom tape and do about 2-inch on top. Same installation as before, fold along the backing, position it while it's not the full thing sticks, okay? Right. Apply the tape, okay? The 2 cuts. All right. Repeat the same step on the other side.
Okay.
Now we have 2 more corners to address. The good news is we do it exactly the same way as we did on the bottom. So one more time, we're going to use the 4-inch. Rough opening width plus 3-inch. Just going to pre-cut both pieces here. Now the last piece that we need for the rough opening is the head. And the head we are going to overextend by 1 inch here so we can properly protect this upper edge here. Okay? So once again, quick measure. Right, oh, that's a little generous. Here we go. Okay, got it. All right, and that will be it. All done and properly sealed. So with good planning, the right product and the correct installation, we just created an air and weathertight building envelope. If you have a project where you would like to talk to us, feel free to fill out the form below. We are more than happy to talk to you. And always keep in mind, get it right, build it tight.